Hello guys, welcome to the day 3 of the boot camp in which we are going to make model that can predict diseases. So welcome back to everyone from the day 2 to day 3. Good evening. So guys, hurry up and message or call your friends to join ASAP so they don't miss anything. Good evening everyone. Just message your friends so that they join us and they don't miss any part. If it's showing waiting for you, please load again. Good evening. So today we are in day 3 of our boot camp. But first of all, we are going to do a recap of this code of day 2 because like many people were facing issue while answering this question in the quiz. So I like to have a again a detailed recap of this code which we have done in day 2. So once we done with this, we will move forward. Okay. So once everyone joined, this message ready in the chat. So I start. Ready? Okay. Shall we begin? Recap of day 2. Yes, we are going to do a short recap because like in the last or I think eighth and ninth question was from these two codes only and like majority got it wrong, only few got it right. So we are going to do a recap of day 2 code. Want recap of day 1 recap we have already done in day 2. So I don't think because it will take time and we have to cover a lot of thing in day 3. So I think we should focus on this. If you want a recap of day 1, day 2, you can guys can go and watch the whole like of day 1 and day 2. Both videos are on YouTube. You guys can just go and check after this class. So let's start and we will move forward. So in this, first of all, in this code, what we are doing is we are actually creating, like we are finding all type of text, like text type column which includes like male, female, or even like chest pain type, etc. So we are first of all finding all types of column which contain the text, specifically text, not the numerics. And when we like we make a list of those columns, then like whichever column contain the text inside that, we make a list of all of them, and then we check if a target column like number, if the target column which we have to give the output column, we are going to check if a target column num is in that list. If it is present, we remove it because num is the answer column in which we are going to give the output to the user, that whether he or she or anyone whose report he has uploaded is suffering from heart disease or not. whether the like patient has the heart disease, we should like not change or encode that specific column. Okay, so we are kind of doing that thing here. So you can just say it encode all objects column equal columns. Okay, so this is we are doing here, and then here we are just removing the like we don't want to encode target column in which we are producing the output. So this was the main thing. I think question was from the first line only, what it is actually doing and why we are removing. So, so this is what it was doing. Like if you take a normal example, think of it making a list of all the questions in the exam. But if the answer key is like numeric column, like if we take an answer key as numeric column, so accidentally it gets into the list, and then we have to remove from the whole list that is target column or the numeric column which you want as a answer. So this is the what we were doing here. So moving with this second thing, x is equals to df dot drop num x is equals to 1 and y is equals to df num greater than 0 dot hash type int. So here like x is all the input features like patient's age, gender, cholesterol, etc. Basically the quotient, x is the quotient of what we are doing here. Like what it means actually is x are all kind of input features, all kind of questions we are raising, and y here the output target, whether the person has heart disease or not. Like y is the answer. If it gives one, it is like called as true condition, then he or she is suffering from the heart disease. And when it doesn't like give, it gives 0, so it is taken as it doesn't have a heart disease. So here you can see like df num is greater than 0. Like it changes the target into 0 and 1. 0 for no disease and 1 for disease present. So we are just doing two simple tasks here, and after that we are just in this column we are just getting all the categorical columns into a final feature columns, nothing special in this. So here I let me write. So if like 0 here we are taking as no disease, and 1 here we are taking as disease present. Okay, so this is the only things which we are doing here. I think most of the people have got this, and now we shall proceed with the day 3 what we are actually going to do. So for the day 3 we are going to train, then train and split that data, then we have to normalization things also. Like I think heading, we are not advancing today, we are training, normalization and testing, and even we can also in the last, if time allows us, we will evaluate the model also. evaluation. We will done model evaluation also if time allows. Otherwise, we will have to do on the day 4. Okay. So we will do this. So we are going to first of all train. Then train and split are two parts of like teaching the anything. Like just suppose in the classroom when you are studying or now also you are guys studying. So when you take like in normal classes, that is the training part, and when the exam comes, that is the test part. So teachers first of all train you guys on all the things which were in the curriculum, and then test the same, test you guys from the same thing from all that. So I think we have to first of all run all the blocks again.
Received 1140 on Google Pay for business.
Okay, I think we are done with all this. All the columns have successfully done. So now from here we will proceed with this. In this, we are importing a tool named as train test split that help us to divide a data set into two parts, like training data first of all and then testing data. For training data is used to teach the model, and testing data is used to check how well the model learned, like how well like take an example of a student. Teacher first teach everything in the class, and in the exam they check how well the student has recognized or studied well in that whole thing. So here, when you take this train spread data, it is like I'm telling, training like practice question you solve while studying, and then testing is the actual exam paper. You don't study from the exam paper, like you have some of the practice question papers, but the actual question paper which is going to come in exam is given on the spot. Whereas training data like practice question are given earlier to like improve the efficiency and the accuracy of a student. Same way, we are suppose the machine learning model as a newly student in your classroom or anything, learning the things which the curriculum already have. The curriculum is the data set. So further moving with this standard scaler. So here we are importing a tool standard scaler that help us to standardize the scale numeric values. Like suppose if you are telling if you are teaching a student, and uh, on one student you are giving 4 5 hours 8 hours, and whereas on the other student you are just giving 20 minutes or 1 hour. So it is not equal. Like while training you are putting more time on one and lesser time on other. So it is not kind of fair teaching methods or anything. So no, today there will no quiz. Tomorrow I will try to take quiz because we have to first cover up the curriculum of the boot camp also. Once we like achieve the target of the day 4, then we will have a quiz tomorrow. So continuing with this, so where was like standardizing the things. So here in this it actually standardize the numeric values. When you go up in this, while see here some like in the trust bp it is given 145 160 120 130 130. The scale of this ranges from 130 to 160 on the first 5 column. Other than it can also increase on this, But in cholesterol, when you give, it has 204, 233, 286, 229. So here's this range is different, 204 and to 286. Where when we come on this, we have scale from 108 to 187. Then again we have different range from 100, sorry, 1.4 to 3.5. Then here from 0 to 3. Then like we have different scales, like different scale for different values, different things. So like suppose if we are going to give a student and tell, like to one student to study a whole thick book, and other student to study a very thin book, so it will not be fair. So here also one one categorical column we are giving the model a very huge range, whereas other columns a very small range. So we are going to convert all that categories numeric columns into a standard form following the same aspect ratio. Here, if you understand, like we are not going to change the if we take that value out of 100, we are going to first of all check the highest and the lowest range, and in that the same ratio will be followed to convert. Same way, when we convert the marks into like percentage, like when you have 420 marks out of 500, so you what you evaluate yourself. So to confirm your evaluation for better understanding, you convert that into normal percentage. Same way here also we are converting that into out of 100 scale. So proceeding with this. Good evening. Okay, got it. So we will move forward with this. Now we are going to first of all train that train the size. We are going to telling what size the training will happen and what size the testing will happen. Okay. So here we are splitting our data set into training data and testing data. So here wherever you like see the X train and X test and Y train and Y test. So sorry. So earlier, as I all told you, all X are the all features like age, cholesterol, blood pressure, all the input feature, and whereas the Y are the targets where the person has the disease or not, the output feature. So after splitting, what we are getting, like we are having X train features. This is the feature used for the training, and then we have X test also. So these are the features used for testing, like the same data for like training and testing both. Then we have Whiten, like you will guys have question, like we were telling that Y is for like targets, but here we are training Y train also. So it and these are the targets label, like what we are targeting, that what kind of target labels for the training, like what target we have used in that. And when coming to the final Y test, and these are the target labels testing, like what testing we have done of from these target levels we are achieving this. Now moving forward, like here we are using the same tool which we have imported, and then X Y, and here we are stating the test size, like out of like consider the whole data set as one, and out of that one we are taking 0.2, and that means 20% of the whole data set. 0.2 is the like 20 upon 100, if you do it is 0.2. So we are taking 0.2% or so 20% of the whole data set as the test data. Like out of whole syllabus we are taking specific some questions to test the students abilities. So in same way we are taking some of the uh, uh, data out of that to test that model later. And here random state 2042, like think of it as seeding to get the same split every time. Like if we run again, it is kind of seeding a model to get the same equal amount of split every time. Without this, every time you run the code, you may get a slightly different train or test division. Like you will get some other part of the data set as training and some other part of the data set as testing in every time you run this model. So here people are saying like 40, 60, 40, and 50, 50 data. No, we are not taking like um, how much time your exam goes on. Your exam maximum goes for 15 to 20 days, whereas how much time your semester takes. Your semester runs for semester classes run for at least 3 to 4 months. So you compare your 3 to 4 months of training with just 15 days of testing. So will it be a 50-50 ratio or 60-40 ratio? No, it is not going to do like that. So here we are just taking as like we have a semester of 5 months. In that we have examination or testing of 1 month, and the rest 4 month is the training part. Like 80% is the training part, and 1 month, like 20% is the testing part in which we are taking. Yes, random state is required because random state will give you the exact training. Like if you divide that part, like every cycle of your semester goes in the same way. Like first you will have your session starting, then you have midterms, then you have pre-ends, and then end terms. Same way it will follow the pattern. Like it will give the same training data to model and testing data while testing. It will not change every time. Okay, so now shall we move forward? hmm. Okay, we have run this much part. So now we are going to scale numeric features, like what we have taken as here as standard scaler. So we are going to scale the numeric features here. So here we are writing the scale is equals to standard scalar. Like we are assigning this function to this word which we are going to use again. It is kind of assigning that same word to not use a whole function. Instead of that we can use a keyword which we have allocated it. So uh, we are like scaling or resizing the numeric data so that all the features are on the same scale. Like earlier I have told you, like every feature were having different range. So we are all kind of converting all that values into according to their range into a percentage. You can say what percentage it is achieving. Sorry. So like some features like age might be intense, like 20 to 80. Then we have some features like cholesterol might be in 100 to, let's suppose, 300. Then some blood sugar or might be in 0 or 1 only, like they have blood sugar or not. So same way we are going to kind of scale them. These are not scaled. The bigger numbers like cholesterol may dominate and confuse the model. Like if I give a student a big thick book, he might think that whole syllabus will come from this only, and he will keep on studying that only. Whereas he will ignore the other small thin books. So to maintain the like equilibrium condition, we are going to standardize all the things. So here, first of all, what formula we are going, what formula it actually use. So here actually the new mean which we, the new value which you achieve here, you have to understand how it like and get from. So from here we are taking x minus mean. The mean, what is the mean? Mean is the whole column mean, like the average of the all the values we have done in that column. Then we are going to divide it with the standard deviation. Okay, so this is the formula for achieving that, like if we are replacing that value, this is the formula we are going to use in that thing. And here we are like already told scaling the numeric values. So in this we are creating a tool scaler that will standardize the number. I think this much has you have got. So moving forward with x train scaled is equals to scale dot fit transform x train. So what we are doing here, listen clearly. Here fit learns the mean and the standard deviation from the training data itself. So here when you are seeing fit, so it is learn the learning kind of learning the mean and the standard deviation from the training data itself. Whereas moving forward with like transform, so it uses them to scale the training data. It uses that same mean and the standard deviation to transform that into a scale which we are using like 0 to 100. As you can see, we are using mean here and standard deviation here, and x is the actual value of that input. Okay, so this is the like method to kind of convert the training data and resize it properly. Now we coming to the second part. X test scaled is equals to scalar transform x text. Now this is the testing part. So here we only transform the test data, like we have already split it that 80% we have received 100% data set, out of which we have already split the 80% data, but we have to kind of transform or the rescale the rest of the testing data also, because if a user will input, user doesn't know what scale we are using. User will input its information in normal day to day normal like values which are oftenly used. He will not scale down or resize it. So here we are also like transforming or standardizing the test data also, using the same mean and the standard deviation from the training. Like we don't fit again because the trained data should not influence the like model, like the questions, like if you got to know what actual questions are going to come in your exam, or what type of even questions are going to come in an exam, so you will get to know everything. Same way we are not going to fit, like here you can see we have done the fit and the transform underscore transform, but here we are not fitting because we are not going to let know the student what type of actual questions are going to come during the testing. Okay, so we have to run this. So this part has got run. So now moving to the another part of another interesting part, like what kind of models and everything we are going to use in this. So While like we have split the data into everything, now we want to know what kind of things are going to be, how like what teaching method it is going to follow. Just a second. Okay, so now we are moving with the line from sklearn dot linear model import logistic regression. I think here all the mathematical students or the btech students must have listened about the logistic regression, like in I think in maths 1, maths 2, this was maths 2, I think in maths 2 it was present. Just comment and tell in which like maths 2 or maths 4 where it was present logistic regression. Why we use fit transform on training data and transform on testing data? Because in fit transform we are going to like train the in that model in x train scale, we are going to train that model with that data, but we are rescaling like standardizing the test data also, but we are not going to tell that model that from this data we are going to train you. So we are not fitting here anything, we are just transforming it. Okay, maths 2. Okay, so maths 2, I think maths maximum guys are telling like in maths 2 they have studied the logistics regression. So that like when you guys were studying, if anyone is here from AIML stream or focused on machine learning, then your teachers might have tell you like machine learning is all about mathematics. So here that mathematics come to your like training part. So we are like bringing in ready-made machine learning model, like logistic regression is a ready-made machine. Like you don't have to code the whole logistic regression logic in this again. It is already pre-made algorithm or logic made under a scikit-learn. Like when you skill learn, it is the full form is scikit learn. So in this all type of like mathematic logics and algorithms are present, so here we have to do. Now there's come more one interesting part, like all those who have not studied, okay, no problem, because even if I'm have also done the btech, but if someone asks that in maths too you have studied a lot of description, explain the whole formula and everything is like people not remember it very well or clearly. So here that's why like people not remember, even if we have to make whole thing we are not. So here only automatic like ready to made algorithms as a functions are ready. So I'm just telling to all these people who have not studied this, there's no problem. So like people must have studied about classification, regression, and etc. But here the twist comes. Despite its name, it is not about regression. This is the kind of interesting parts, but it is actually about the classification, like predicting categories like disease or not disease. Yani ki, uh, it means to give in either way, it has or it has not during with the help of classification. If you say classification, okay, so we can run this. So we have imported the logistic regression into our system, and then we will move forward with the coding part. So now coming to this, you guys are commenting. Attendance will be given shortly to you guys in like 10 minutes. Just wait for 10 minutes more. By 7:45, we will give the attendance. Okay. So there's no need to get. What happens if the random state 42 is changed to 22? Nothing will happen. It will like in random state 42, I'm just telling a range from where I want training data and from till where and where I want the testing data. If you change the numeric 22, it will just change the range from the data set. There's no it is not going to give any such error. I request you guys to not spam useless things or comment. Okay. And yes, deep learning is fun until and unless your model runs into overfitting. Yeah, and like I think people are here have suffered from overfitting. So that's why we split data and then train. We not overtrain the data. So like if suppose I have given the testing data also, the accuracy will reach very much like 99 100%. So it is not very good. So that's why over we have to provide overfitting. In the like WhatsApp group you will be given the link on I think day 5 and after date that on the after day 5 also you will be given a time of 1 or 2 days to complete the project along with a 5 slides and I think 30 to 1 minutes 30 seconds to 1 minute video of predicting your output. All the like details like on the last day I will give you GitHub link with a like sample readme also, which you guys can use to like create your portfolio, and like you guys can add all these project in your resume also. Explain the basic difference. I've already explained the basic difference with scalar fit transform and scalar transform. In scalar fit transform, we are transforming as well as giving that data to the model for the testing. Whereas in like scalar transform, we are just transforming. We are not giving that data initially to the model to train itself. Okay. GitHub link will be given to you guys on the fifth day. We will work upon GitHub and portfolio and everything on the day 5. Okay. So now moving forward with this, what you guys are commenting again. So now, okay. Yes, the same project is need to be submitted. Like the project you guys are working upon side by side. All the students who are working side by side, they don't even need the 1 or 2 extra days time. They can like upload the same day if they are working. You just have to like once you complete all this you have to just go on the files, and on this you will get an option of download it as ipynb file, and once you have downloaded you can just upload this as a your project on your GitHub, and you can guys submit that GitHub link also. So there is no need to worry about that. You just have to prepare a 5 slides about the project which you have done day by day, what you have achieved, and then we will go further move with like doing things such as um, working up. Then you have to just make, I think, 1 minute video that you guys can do using Zoom or OBS Studio. So just you have to upload the uh, tell about what actual project is about. You have to upload a sample file. I will provide you guys a sample file also, because a sample CSV file, a part of the training testing data, that all the things will be provided to you in the group and even in the GitHub link also. So there is no need to. Yes, it is compulsory to submit all these things. Okay, I think questions are done. Let's move forward because we have limited time. So here, LR model is equals to logic section. So we created a model object like making a blank machine. We are like right now it know nothing. It's just ready to learn. We have, this is kind of giving admission, giving admission to a new student. Okay, it is just that. So and further moving with this is the main training step. Here you can see like I have given a command fit using a train scale and the y train. Like I have the target training data also, and the like input training data both I have taken here to train the model using the, like here I have imported already what kind, like here I'm telling giving the admission as well as telling in which class curriculum, like I have to teach that student a class 9th curriculum, class 10th, or anything, or even a BTech student curriculum to that, and in that curriculum what we are going to use. Like this is the training step, main training step. Okay. Yes, you have to submit the 5 days work which then collab as a project. So this is the training step. So here we feed the machine two things. First is the like X trained scaled. So here these are the input features like age, cholesterol, blood pressure, like as or any all the columns which we are going to input here, which we have already scaled in the range of 0 to 100 um, from its original scale, like using all the standard scalar method. So and the second thing which we have taken here comes as y train. So it like have the correct answers 0, like if any student answer in the class, like if a teacher asks you a question, what is anything, like what is chlorophyll, so if a student answer that, so teacher has a duty like while training that whether he or she has tell the right answer or not. So here we are going to tell that yes, while answering this you have answered the correct answer, like white train. So it contains 0 for the no disease as we have already done, and 1 as the disease. This way the model learns the pattern relationship between the features and the disease outcome, like like what features has to be present or to be in a positive side, so and the disease has to become to a true state, like one state as a disease present. So this is the training step in which we are doing here. Okay, don't, I am again repeating, don't spam again and again. Now here it is like telling what kind of model we have used here, like it is telling fitted, like model has already been trained with the fitted data. Okay, Yes, we are working on supervised learning. Like we have already taken the data set. When we have already data set present, like data, we are working on the supervised data. We are just telling what patterns they have to follow and everything. Whereas if we like, uh, we can also have like, it will take time to get trained, but we have to make a model in such a way that user inputs its all the reports and everything. And for in the initial phase of training, the user only tell that, according to this report, I was diagnosed with the disease. So in that way we can work upon the unsupervised learning. So I think we have done with the train test split normalization and of then modeling also. Like here we have done the modeling. So let's come, like I think we have time. Okay. First of all, give I will give you the attendance link. Just a minute. Today is day 3. I think yes, day 3. So I've given the attendance link in the chat. So now don't spam users thing, otherwise it will get. Yes, on the last day, I will tell you guys how to connect the project on GitHub. That day, we are going to do all these things, like the final prediction. What we are going to on the like next day, on the day 4, we are going to hyper tune the models, like uh, more tell, like we will take example, we are taking an extra class of the student. Same way we will do some hyper tuning of the model and then advance that data set. And on day 5 we are going to do the prediction thing, like we will tell the model that we have uploaded a file, and according to this, upload the prediction. So moving forward with that, we will tell you guys how to, like I will provide a GitHub link also, and tell you guys how to link your project to the. Okay, my full name is Ishan Mishra. Like, name is not been. I think display name should come up. Okay, you guys want LinkedIn? Okay, wait. You guys, like, if have, don't message anything. If you have any doubt, you guys can just ask the doubts only. Okay, I will try to answer maximum, but if I will, if anyone got missed, then don't get like annoyed. So I think we are done till like modeling. Now we will move with model evaluation. All the students, please copy the attendance link in any other new tab and move forward with this. You guys can do the attendance link later on also. The link will be open after some time also, class after some time of the class also. So now we will move with the model evaluation, like what we have done till here. So how that model is going to be present in our system. So we are going to take that. So we are like every examination, after every examination we have some metric system. So in this we like instead of building a whole new metric system, we will just have a kind of print the things, and we will check what type of accuracy scores a standard like in industry. When you go in the ml industry, you will listen about things such as precision, recall, f1 score. So these are kind of most used things in the ml industry. So we are going to use that same metrics while evaluating our model. Like we are building a industry level like projects, so you guys are getting ready for the further placements in your data science. So we are going to do that same thing. So now we are going to import the accuracy score from the skitlearn metrics, like the same skitlearn. Like from here we have imported the model selection and pre-processing standards. Now we are importing the metric scores, like kind of metrics evaluation method from here. So we will run. It is very simple, like we are just importing like a tool that helps uh, to check how good our model is. Like after training we need to test also it, that these function are like exam checkers for the model. It is just like this is the uh, in your exams you get percentage grade. So here we call recall, f1 score, and etc. Precision, how precise the uh, work has been done and everything. So moving forward with this, we have to do load this. Okay, what you, there are already predefined metrics system for this AI predictor. According to that, yes, the notebook will be shared. The notebook will be shared. Uh, you are not able to understand what we have to do in this project, then you have to like go and study from day one. In the day one we have briefly known about this project we are going to achieve and what we are going to build. So you have to go after this class ends, just go on day one video, have a whole look what this whole project is, how to set up the collab, how to import data set and everything. Once you are done with this, uh, once you're done with this, you have to move forward. Okay. uh, you are doing a mini project with smart healthcare and recommended diet plan system, how to combine both. So if you have to combine both, um, you have to like build a whole data pipeline in which you will be called like at the last you have to build a interface in which you will be calling the both. Like the model training will be done separately of both, but once you done the model training, you have to build an interface in which both will uh, react. Like once the like you are recommending a smart healthcare and recommend a diet plan. So if you pass the data from one model to another to check if there is any disease present, and if there is disease present, you have to build a you need to have a pre-built data set of diet plans also. In that It will recommend the diet plan to the user according to the disease he or she is suffering from. So this way you can integrate this project, or you can like have multiple ways to integrate project you can explore. What's the accuracy of such AI predictor? Accuracy of there are some metrics or the standards which we have already set to check the accuracy system. We are going to use that also. Yes, if you have missed the guest study class, no problem. You can just go on YouTube channel of DevTown, and the second last video, I think the will be present of that only. After we finish this video, you can go and check this. So let's move with this as we are close to the time. So here we are going to like in this line y predict dot lr is equals to lr model predict x test scale, like the test data from that scale. So we take in this we take our training data like trained logistic regression model, the which we have done here. Mm, yeah, here we have taken and then like x trained scale. So now we are further moving. We take a trained logistic regression model, LR model, which we are going to like take here and ask it to predict whether the patient in the test set, like the test set which we have separated earlier only, uh, have heart disease or not. As simple as it. Like we are asking them to predict. The predictions are like then saved in a separate file name as ypredicts.lr, like logistic regressions predictions are stored in this already. So now we have like y test, the actual answers, the real patient which we have, and the y test and the x test which we have initially taken. So in this y test, the actual answer, the real patient conditions, and then we have y prediction lr, like here the y prediction lr, after doing the prediction, the model's answers, the predicted answer. So we have two things. Okay, so now we are going to like compare the actual answers of the y test which were present in the this y test which we have taken earlier as the answers which were present. So as that, and compare with the model's answer like y predict lr, the model's answer which it has given recently. Okay, and then accuracy score, it is going to tell, it is going to like tell us the percentage of correct answer, what percentage of like out of 100 answers which have model made, how many of the are correct as mentioned in the y test. So take an example, out of 100 patients, the model guessed 85 correctly, like then the accuracy will be like 85%, like 85 upon 100, so the accuracy will be 85. Okay, then we are just this gives a detailed scorecard of that, like here when we are giving the classification report. So we are asking to give a like detailed scorecard of the model, like mentioning in each department or each subject how much he has scored well, and what the accuracy level he has achieved in specifically that column. Like when we have like precision, we have like let me first run and then you will classification report is not present. Um, Okay, sorry. Here you have to take one more thing. Just you have to import one more function. We have forgot. When you run this again and Okay, here the classification report comes on. So when the uh, taking when we are talking about the classification report, first of all, the accuracy, the percentage which for which I was telling is here like 84 point, like 84.239, like when you convert this in percentage, it is 84.29 something percent. So it gives out the this much accuracy in, like it has made 100, let's suppose 100 predictions. Out of that, our model has correctly predicted the 84 correctly, and it is considered to be a good score. Like the if you have accuracy score above 75, but if you have accuracy score between like accuracy score between the range of 75 to 99 even, let's say it's 98 only, it is considered to be a good score for the model. But when you reach the score near to 99 or even 100, 99 is also okay. But sometimes if you achieve the score of 100, and then understand your model got spoiled with the overfitting, so you have to train again. So, and now coming back to this, consider to be good. Okay. So now coming back to classification report of our system. So here you can see, first of all, two things are present: 0 and 1. Okay. So what are 0 and 1? We have already discussed here. Like when you come, this is the 0 and 1, what we are taking there, like it is a output, the target column, or you can say the numeric values which we are focusing about. So on this, like on every 0 and 1, like every true and false, we are having a precision, recall, f1, and support. Okay. So coming to the precision, when the model said disease, how often was it right? So precision is that, like when the model tell 0, like no disease, it was correct 79 times, like 17. We are taking we are supposing that our model, the test data was 100 values, the 100 patients were given. Out of 100 patients, 79 were given, uh, like out of that, disease. And when it has given one, like disease present, in that 88%, like out of 100, 88 times the model was right that the patient is suffering from disease. And taking the average value of both, like 79 and 88, we have received an like average accuracy of 84. See, here is the average accuracy which we have received. And then moving to the second part, we have recall. So out of all people, like out of all the people who actually had the disease, like we are taking here the real data which were present earlier. Okay, what are you guys spamming? You didn't receive the appreciation certificate. Please contact the DevTown team. They will surely resolve your issue. You can mail also, on even WhatsApp also, you can ask them, you can just message them, you will get the resolution. Okay. And don't spam, otherwise next time I have no option uh, rather than blocking you. So don't spam unnecessary things. You can, and you can just directly go and ask the team, they will surely resolve your issue. Okay, so moving back to this recall, as I told you, like out of how many people who were actually had the disease and how many the model catch, like if we are taking 100 people's having and not having disease, so out of that 83 times our model give it correctly that these people are not having disease than actual data, and same in the disease section also. Then moving with the F1 score. F1 score is a balance between the precision and recall. Like it is kind of good for both are, if like both are highs or both are lows. So it is kind of an average of both the things like pre-call, precision and recall. Okay, and then we have taken the macro accuracy also and the weighted accuracy also. Almost uh, both are same in this section, and this accuracy is then we have received as a regression accuracy. Okay, so I think the time is also done. So overfit, if you want to know about the overfit and the underfit, and first of all I'm going to tell you, please don't like put the same thing again and again. Like you're asking the same question three times, so don't do that. I'm going to tell, just have some patience. So overfitting is a condition in which while training you give more data than the required, like you train too much. Let's take an example of a student. Okay, a student needs to study 6 hours or 8 hours or 9 hours, which is supposed to be a good time for a student to study. When the student exceed, like when you push a student to study again and study continuously, just study. Like if he's going to study 18 hours, 20 hours a day, like we have only 24 hours, and out of 24 he's studying for continuously 18 hours, then he might get some mental issues, I think, because sitting at a place constantly and studying and over memorizing, or like over memorizing you can say, so he will get like crazy. So in that condition we call it as overfitting. Whereas coming to the underfitting, underfitting is like a student needs to study 6 to 9 hours a day, but he's only studying 1 hour or 2 hour maximally. So he doesn't remember anything, he doesn't have any focus on study. So that is a condition known as underfitting in machine learning model. Like in this, when we don't provide sufficient data to the model, it go known as underfit data. Okay, just a second. Okay, now don't spam. The spammers will get blocked if they just get on spamming the same thing after answering also. Some people are asking like where they will get the real data set, the huge data set. Like real data set will not be given like in public spaces, like you will not get exactly real name, real data set, because it will be a huge privacy concern. But instead of that you can get a dummy model which you can take for training and everything. It is, you can consider that as new as a, like as original as the original data set, because information on which we are going to and have, it is kind of original, only the name, age and everything is like kind of encrypted or masked with another thing. So you can take these data set from Kaggle, like you have huge sets of data set, like real new updated recently updated data set, then older data set also, which people are using from very long time. Okay, so I think we are done with this till here, and people have registered, like done with the attendance, so we end today's session, and we will start our day 4 with like having some random forest as and feature importance also. Like we will do some we will plot some confusion matrix, and then we will have some random forest comparisons also. Then we will do some hyper parameter tuning, like we will uh, guide them more with kind of extra tuition, you can say, in reference to student. So we will do all these things tomorrow, and also we will save the model which we have trained. So let's get back tomorrow at the same time, and now I will end this session. If you guys have any doubt, any genuine doubts, you can comment. I will wait for 1 or 2 minutes, then I will end the session. Okay. Mm, yes. Mm, yes, if you get the real data, you can replace the data set in Kaggle, or you can just, instead of replace, you don't have to like, go and upload. You can just directly like in here, when we were importing that data from Kaggle, you can just skip all these steps, like from here to here you can skip. Instead of this, you can just directly upload this file, real data set here, and then like get the um, path here. Like you, if you want the path, you can go and like come in here when clicking on 3 dots, you will get an option copy path. You have to just copy that path and come and paste it here, as simple as that. You don't have to get replace all the thing. Just skip all these steps and move forward. Okay. LinkedIn, I have already given above in the chat, so you guys can go and check. I've already given in the chat the LinkedIn ID. You are getting error on Kaggle. Please share the exact error so that I can tell what exactly. Instead of, I would like just a friendly suggestion to you all guys. Instead of just focusing on like you guys are behind certificate, I know certificates are important to prove your skills in LinkedIn or any professional platform, but try to with like certificate, try to focus uh, on project also, for actual what thing you are here. Instead of just focusing there, you focus on this also. You guys, like if you don't have received the appreciation certificate, you guys, I'm again repeating, you guys can contact the DevTown team. They will surely resolve your issue. And now please don't comment again and again like you didn't have appreciation certificate. Okay, so now I would like to end this stream here, and we will get back to you tomorrow at the same time, 7 to 8 8:15. Okay. So bye bye, Tata, and see you guys tomorrow with the same energy and booming enthusiast. So bye.